In this discussion, we're going to be looking at the importance of water in rural lands, in rural land use, and we're going to really be looking at probably three aspects of water. One is the physics, if you like, of water and its importance. The second is a brief coverage, if you like, of the importance for farms and operating farms. And the third is the regulation of water, and in fact the whole regime of what is now known as water property. So, we all know about water because it's mighty important for life. Plants need it to grow, we need it to drink and wash our cars and whatnot. We use it for a lot of industrial purposes. Rural Australia is very conscious of water because Australia has not a lot of rainfall, and what it has tends to often come at the wrong times. Either not very much for a few years and then it buckets down and floods everything. And so water has been a major issue, a major concern in Australia ever since settlement and farming was begun. But let's take a step back and look at this stuff, water. The delightful thing about water is that it doesn't go away. And in fact, what it does, it tends to circulate around the planet. And in fact, so much of it circulates, and its circulation is so important, that we wouldn't be able to have life on Earth without it. Now, it's pretty obvious because we get very thirsty if there wasn't any water, but it's a lot more than that. Something like 496,000 cubic kilometres of water evaporates off the planet and eventually precipitates back down as snow or rain. In doing so, the water is purified. And so if I have a dirty bucket of muck in the backyard, that left in the sun will eventually dry out, the water will go up in the sky and it'll rain down somewhere else, absolutely pure. Isn't that lovely? And so it's nature's way of cleaning itself, certainly cleaning this extraordinarily important element in, or compound in the earth. Obviously, it's needed for water. It's needed for life. You know, we need to drink it. Fishes need to swim in it, and plants need it to grow and flourish. But there's another aspect of water which is often ignored and really deserves a lot more attention. That is its contribution to the temperature control of the planet. We mentioned 496,000 cubic kilometres. Now, it's easy to talk about big numbers. They don't really mean a great deal. What's a litre? It's 10 centimetres cubed. What is 1,000 litres? Well, it's a cubic metre of water, basically. When we talk about cubic kilometres, though, that is an awful lot of litres, and I'll let you go off and think about how many zeros are involved in that many litres of water. It's an awful lot. And by the time you consider how much energy is absorbed in taking liquid water, which might be sitting on the ocean or sitting, you know, on the clothes, on your clothesline in the backyard, or maybe out on a damp paddock after a morning rain, how much energy is required to turn that liquid water into water vapour, which then kind of floats up? It's a fair bit. Scientists will tell you it's 540 kilocalories per mole of water. Now, I won't go into exactly what that means, but one of the curious things about water is that it absorbs a lot of energy as it goes from the liquid to the vapour state, the gas state. That has the advantage that if you want to cool something down quickly, about the best thing you can do is throw water on it. Oddly enough, if you throw oil on it, you don't cool it down so quickly. So water has this tremendous capacity to absorb energy. Why am I mentioning that? Because the control of the Earth's temperature largely has to do with the solar radiation that comes in from the sun, hitting the Earth's surface, and then it needs to get away somehow so that the Earth doesn't heat up, basically. And so the Earth maintains its temperature balance because one way or another it is able to release the temperature and get rid of it in some way in order to remain nice and constant temperature on the Earth's surface. Otherwise we'd all sort of fry. It turns out that water is vitally important with that. That 496 cubic kilometres actually absorbs in its evaporation phase over 90% of the sun's energy that hits the surface of the Earth. What that means is that the amount of the sun's energy which is reflected and radiated back upwards is relatively small. It's only about 7%. And so what does that tell us? It tells us that the Earth's temperature control system is largely due to the evaporation and condensation of water. That's very important when you're concerned about things like global warming and the effect of carbon dioxide on the temperature balance on the planet, because it's not the carbon dioxide which is really doing a big part of the job. It's actually water. And that is especially the case when we look at the other aspect of water in the Earth's temperature control system. We've all heard the expression greenhouse effect and so on. It's that layer of gases in the upper atmosphere that tends to reflect heat back down to Earth. It becomes like a blanket. Now, we often are concerned about some of those greenhouse gases changing, maybe becoming more intense. If we were to have our greenhouse layer get as intense as, say, Venus, it would be very hot. In fact, on the surface of Venus, it's so hot because of that intense greenhouse effect that there cannot be any liquid water, liquid most anything on the surface, because there's this extraordinarily intense vapor layer. It's actually sulfuric acid, not so much water, but it does the same thing. On Earth, over 90% of the greenhouse effect, in fact it's considerably more than 90%, it is made up of water vapor. Carbon dioxide and other what we call greenhouse gases are relatively small players. To give you an idea, water vapor is in the vicinity of a few tenths of a percent, whereas of the atmosphere, whereas carbon dioxide is in the vicinity of 200 or 300 millionths of the Earth's atmosphere. And so when we're talking about parts per million for carbon dioxide compared to, let's say, parts per thousand in water vapor, it gives you an idea of just the relative intensity. Basically, over 90% of the greenhouse layer is actually water vapor. What does this mean? It means it's an advantage to have lots and lots of water vapor in the air if we want a nice healthy greenhouse layer. And a nice healthy greenhouse layer keeps the Earth nice and warm so that we can live on it, not freezing cold. For those of you who have travelled on airplanes and looked at the navigation screen that they often put up on the back of your seat, you'll notice that when a commercial jet gets to its flying altitude, it's already above that greenhouse layer. And the temperatures up there are pretty chilly. They're sort of in the vicinity of about minus 50 degrees Celsius. Not a very comfortable climate to live for you and me, and certainly not a very productive temperature to be growing crops. And so down on the surface, not only do we use water to water our plants and give our cattle something to drink, we're actually relying on the water vapor that is in the atmosphere that's actually keeping our planet at this nice warm temperature. In fact, the blue colour in our sky is there because of the water vapor which is in our sky. So there's a lot of stuff out there. It's very, very important, I guess, is the take home. And so we have water very, very important in the rural situation, because it helps enormously in keeping our farms at the right temperature, as well as providing all of the things that we need for life. Curiously, while we're on the topic of farms and keeping things alive, we can also look at the importance of carbon dioxide for rural Australia. In fact, rural anywhere. Carbon dioxide is one of the gases that plants absolutely need. It's their food. It's like oxygen is to us. Plants require carbon dioxide as an input to their photosynthesis process, which is where they turn carbon dioxide and some water, oddly enough, into food and other useful chemicals for the plant to grow. Eventually, we eat those plants, and so the carbon dioxide, which has been turned into useful chemicals in the plant, becomes our food and keeps us going as well. And so really, you can say that not only do plants run on carbon dioxide, but indirectly so do we, because we can't live without eating something which is at the end of food chains of varying lengths that all go back to plants' photosynthesis and basically the gobbling up of carbon dioxide. Why am I mentioning this? Because if you want to grow things really quickly in, let's say, rural space, especially in difficult climates, say in the semi-arid regions of Australia, and also, oddly enough, at high altitudes where things are a bit cold and the air is a bit thin, and sort of plants do it a bit tough. One easy way, one very effective way of increasing plant productivity, the growth of plants, is to actually fertilise them using carbon dioxide. And in fact, farmers have started doing that, especially in intensive greenhouse situations, where not only do they use the greenhouse to keep the heat in and so on, which is what we're normally told about greenhouses, but they also have things which are curiously referred to as carbon dioxide generators. And a carbon dioxide generator looks a bit like your gas barbecue turned on its side. It basically burns propane, which produces carbon dioxide. You have to keep it at a bit of a cool level because you don't want to barbecue your greenhouse, but tomatoes and so on. But by putting that carbon dioxide into your greenhouse, you actually multiply the speed with which your tomatoes and your carrots and your celery and whatever else that's going on in there is going to be growing. Not only does that work in greenhouses, but it also works in nature. The neat thing about high levels of carbon dioxide is that it increases plant growth. Yep, okay, we've just been talking about that. It also reduces the amount of water vapor, whatever, that the plants need in order to thrive. And one of the nice things that we've seen in recent years is that with the increase in global carbon dioxide, we're actually finding that plant growth has been stimulated quite considerably. We've seen it in high altitude dry areas, in places like the United States, across the top of Europe, in the Russian steppes. We have forests growing in places that previously were above the tree line. In other words, above that area where trees were supposed to grow. Why are the trees able to grow there now? It's simply because they've got this nice fertiliser, extra carbon dioxide. We also find that in places like Australia, the effect of desertification, the growing, the march of the desert sort of coming out, is actually slowed down when you have higher carbon dioxide levels. And the reason for that is that plants can survive and thrive in a drier environment when they have more carbon dioxide. And so by us putting more carbon dioxide into the air, we're actually helping to stop deserts from growing. And that also means that we're helping farmers to be able to grow more stuff in what were previously more difficult environments. And even in good environments, we're noticing that with extra carbon dioxide concentrations, you don't want to overdo it, but in the growing carbon dioxide concentrations, we're finding that a lot of plants are growing faster, and this is especially the case with trees. Okay, so I've been looking at some of those mechanics of getting things to grow, especially related to water. We've sort of talked about our best part of almost 500,000 cubic kilometres. And you just think about trying to swim in that. It's just an enormous amount of water. The other side of the of this whole process of evaporation and condensation, precipitation, is that the water is relocated into more useful places. And so the water comes out of the ocean. After all, the ocean covers about 2/3 of the planet's surface, so it's obviously going to be catching 2/3 of the sun's light hitting the Earth. Goes up, runs across, and it then precipitates. It rains back down. Normally we think of the rain as washing down the street and eventually getting into our creeks and rivers. However, it's a little bit more complicated than that. Up to 90% of the water that falls on the ground through precipitation, rain or snow or sleet or whatever, actually soaks into the soil. 90%, that's a fairly big percentage. And so what we see flowing down the river is actually the little brother. It's only the tiny part. The remainder soaks down into the soil. It sort of makes the root regions moist, which is mighty good when you're trying to grow something, to have moist roots. It will grow, it will soak down even further until it gets to a geological level which is impervious, in other words waterproof. And there the water sits on top. I guess you could almost do this at home as an experiment. Get a plastic bucket or something, put 20 centimetres of sand in the bottom of it, and then sort of throw in a litre of water. And you'll probably find the litre of water will just disappear. And that's basically what happens when it rains. Most of the water that rains out of the sky kind of disappears. Some of it gets into our creeks and we make a big thing about it and we swim it and do all the rest of it. But most of it just disappears down. It actually is like in the water in the bottom of your bucket. It soaks down until it hits some impervious layer of rock, and then it just sits underneath. This gives us what we call artesian water, water which is underground. In the olden days, when we think of stories like Cinderella or what have you, everyone had a well, because they found that the easiest form of water supply was to simply dig a hole, and that takes you down to a depth under the surface where the water is sitting, and you can just pull it up in a bucket. And we've all been exposed to enough fairy stories to be very familiar with wells and the magic of them. In Australia, the idea of water under the ground in apparently dry places is even more magical because it really keeps many parts of rural Australia alive. Usually our wells aren't open wells. Usually they're deep holes in the ground which are lined with pipes, usually steel pipes. We call them bores, and they're able to pierce down through the earth somewhat deeper, and we pump out the water as a result, and we're able to use that for all of the things that we need water for, especially in a rural situation, to feed our animals, and in some cases do a bit of irrigation, but mainly to feed stock. So bore water is very, very important in many parts of Australia. In fact, Australia has so much water underground, the artesian water, that a large area of Australia, if you go to the study guide, you'll find that we talk about the Great Artesian Basin in Australia, and you'll see where that is. Queensland is very well served by the Great Artesian Basin. It's the biggest area of underground water in the world, or at least one of them. And so it's mighty important. It's important because it keeps a lot of rural Australia alive. Because of the nature of the water flowing down or sitting in a puddle under the ground, depending on what the geology around it is, the minerals is around it, artesian water often is highly mineralized, and oddly enough, sometimes it gets rather warm, and it depends on the temperature and the effect of the heat lower down, sort of under the surface of the planet, and so on. And so artesian water is a bit of a lucky dip. The water will come up, sure enough, but it might have minerals in it, so it might be a bit ugly to drink. It may even be so saline that stock may not even like it. It's a matter of finding what you can. It can also come out quite hot. Those of you who have spent some time in the bush, you may have come across some places where the bore tanks, where the water comes up out of the bores, they actually put it in very large, open, shallow tanks, merely to cool it down, because it comes out of the ground so hot that you actually sort of can't use it to feed stock and what have you. And on a nice day, there is nothing nicer than relaxing in the mineralised hot water coming out of a bore. It's a delightful experience. Not something that inhabitants of Brisbane or Sydney are probably likely to enjoy. But we do rely on it for very practical purposes as well. Okay, so water goes to a lot of places. It's mighty important. It controls the temperature of the planet, keeps things alive. Australia doesn't have much of it, and unfortunately what we have tends to turn up at the wrong time. That's created a problem. And the problem is that as we change our land uses, basically into more intensive, more valuable, and often more water hungry, we're getting to the stage where we have the capacity, especially with big pumps, to pull, in some cases, more water out of a river than is flowing down it. And you hear people talking about from time to time, rivers flowing backwards when they switch the pumps on, in some large agribusiness kind of process. I think that's a little bit of an exaggeration, but it's not that far off. We have the capacity to suck a lot of water out and take it to places where it's not normally meant to go, which can often mean that people downstream don't get much. That became a concern towards the end of last century, towards the end of the 20th century. And there was a lot of discussion as to how to control, how to regulate water use so that it would be used most effectively to foster the best economic benefits for Australia, and also to make sure that we didn't have our rivers turned into some sort of ugly ecological disaster. And so there was the recognition that we needed a more advanced approach to the regulation of our water use. That was pretty much a major research issue during the 1990s, and it ended up with the creation of what we now refer to as water property. Water property is the attempt, well, some would say it's successful, some people say it's a bit of a guess, whatever it is, it's the attempt to turn access to water into a property right. That happened largely around the turn of the century. And in many parts of Australia, in the year 2000, the year gave rise to what in many states are called the Water Act. So there's a Water Act in Queensland, a Water Act in New South Wales, a few other states, and there's also a Commonwealth Water Act. The idea of the Water Act was to use what some people would call neoliberal economic market theory to cause the community to use water most effectively. It does that by saying in the old common law regime, if you owned land that fronted onto a stream, you naturally, at common law, had the right to use the water. In those days, in earlier days, people would seldom use water for more than taking their stock down for a drink, maybe having a bit of a paddle and a splash in, maybe drawing a little bit out with buckets or primitive pumps, and so on. But when you have the capacity to have high-powered, high-volume pumps, that's a different routine. It was also recognised that there are some places, some soils, that may have been away from the river that would really benefit from water, and you'd be able to make them really productive, even though they were pretty dry and not very productive by themselves. Water property is the separation of that natural, that common law access to water because you happen to be living on a riverbank or a creek bank, separating that from the land. And so the right to draw water out of a river or a creek, some sort of a stream, was separated from the riparian rights which naturally or commonly attached to land which was adjacent to the stream. Now that seems like a good idea, and generally it's come on as something which has enabled us to increase certain land uses, so it has had its efficiencies. You probably are aware from maybe your school studies about the Snowy Mountain scheme and what that's done to the more, I won't say inland part of New South Wales, but to the west of the ranges, what's called the Riverina area, and the increase in rural productivity that's going to happen from that. Similar thing has happened with water property. It means that we're able to use water far more intensively. A fair bit of the cotton industry, for instance, pretty much relies on the access to what in previous times would have been a very unfair amount of water. The idea is that you might have some farmer who's next to a river and is not likely to want to take very much water out of it, simply wants to run cattle or something, doesn't need very much water enhancement on his farm, and he will sell his right to take water out of the river to the farmer next door who might want to grow cotton, where he needs a pretty elaborate irrigation system and to be pumping a lot of water here, there and everywhere. That's very, very simply the water regime. You can read about that more in the study guide. I mentioned that there is the Water Acts that started in 2000. In Queensland, they were amended several times, 2013, 2014, 2016, and I think 2018. So they're kind of being tweaked along as we go, but it's still the Water Act 2000. And the purpose of the Water Act is to regulate water property, and that's largely been effective. Now, water property becomes fairly complex, and rather talking about it, I'll let you read about that in the study guide. There's really a hierarchy of water property types. There's permanent water, there's high-risk water, low-risk water. There are water licenses which allow you to take out for a limited period a certain amount of water, and there are water entitlements. And I'll let you go through all of those terms and so on in detail. I do recommend that you print out the study guide and read it, probably with a marking pen and a pencil, because some of these terms get a little bit confusing if I just kind of rattle them all out to you. Water property now, it means that it actually puts a different dimension, extra dimension, into the valuation of rural properties. A farm, when we're talking about those two farms by the river just a short time ago, one where the farmer isn't interested in using his natural water rights, so he actually sells it to the farmer next door. Farmer next door then puts in all this irrigation system and starts growing cotton or rice or something else that uses a lot of water. And so both are happy. One gets a bit of money from selling his water rights, and the other one gets to grow a high-value crop. And so that's a good thing. So water trading means that you then are able to separate the land and the water. That's good. It's not so good, though, when the farmer on the dry lands decides to sell his dry land to someone else who comes in, some bright-eyed chap sort of coming up from the city or something, and he decides, he's sort of thinking to himself, oh, the old farmer, he's just been sort of running cattle out there. I'm going to take that land and, grow cotton on it, because that's what the farm next door is going to be, and if the farmer next door can do it, I'm going to do it. The problem is he gets onto the property and then discovers that he can't grow cotton because he can't take the water out of the river, sorry. That means that the land, the dirt, is not worth very much, potentially, as a result of the fact that it's dry. It doesn't have access to the water. What the balance is between the value of the dirt, of the land, compared to the value of the water is actually a bit of a puzzle. If you talk to most practicing valuers at the moment, they will be able to give you off the top of their head a bunch of numbers for the various types of water rights that you're likely to be able to get in a particular location. But the question that I think I would like you to think about, to ask in the back of your mind, is the value of water at present the right value? That's a little bit tricky. It's one of those places where valuers, like a number of professions, tend to work in practice on rules of thumb and what's common practice and so on. And often they are not reflective enough to think back and say, well, what is the contribution of the minerals and the soil and all the rest of it to the growth of whatever I'm going to grow? What's the relationship of that to the H2O, to the water rights? And how do you split that up? It actually becomes difficult because if you want to grow, let's say, your cotton, you do need a particular type of soil, or at least a particular level of soil quality, and you do need water. Which one's more important? Who knows? Once we separate water from the land, oddly enough, we make it very transportable, portable. Maybe not portable. You can't take water rights off the Darling River and apply them to the Swan River in Western Australia, obviously. But you can shift them up and down the catchment, within limits. But the other thing is that water property is curious because it's a far purer form of real property right than land. When you think about it, land is always stuck locationally. It's also requires a certain amount of maintenance. You've got to fence it, you've got to keep the weeds off it, you've got to do a whole lot of things to it to keep it up to scratch. Whereas water is simply that right to a certain volume of stuff which is relatively pure H2O. You don't have to worry about the weeds, you don't have to worry about the fencing. The water right itself doesn't even have anything to do with the pumps that you might use in your irrigation. And so the water property right itself is very simple. It has the uncertainty of not knowing when you're going to be actually take it out of the river. If we live in drought, parts of Australia are in drought almost constantly. Certainly right now, we're on the edge of drought. People in recent times have seen serious droughts in many parts of Australia. What's the point of having water property rights if the river is dry? Okay, so there's a certain amount of risk with water property at the best of times. But this question of what is the correct relationship in value between a megalitre of water or whatever and an acre or 10 or 100 hectares or whatever, or some sort of amount of land. That is a curious question, which I'll simply leave you with to puzzle over. From the valuer's point of view, from the very practical valuer's point of view, it's a lot easier than that because you'll find that there are norms and recent trends in the value of water, certainly in the value of water in a district. And so you don't have to think about those deep and challenging questions. You simply have to look at your property. Does it have water rights? Does it need water? How much would the property be worth if it had water? They're probably more complex questions to do with the management strategy that you want to take. But definitely you've got really sort of two parts when you value a lot of property in Australia now, because you've got the value of the land and the value of its water rights. Sometimes you can do them separately, so you've got to be very careful with your assignment. What does your client want? What does the property need? What is common in that district for that land use and so on? So they're things to take into account. In general, like most other areas of property, the best way to learn about water, the legal sides of it if you like, is to sit at the feet of somebody who is working in the area, and you'll pick it up pretty quickly. There is a number of the technical sides to it. Obviously, we're talking about a property right which is transferable. We're talking about something which, as I say, is portable, but only within a certain range, and you'll be able to sort of see what those ranges are. As I say, you can't pick water out of one river and water rights, water property out of one river and apply it to another, and so on. And you'll find a number of those details in the study guide. So I recommend that probably now, if you get into the study guide, read through it. But also, as you go, look at the Water Act for your state or its equivalent. Look at the amendments, go back to other commentators and so on that are talking about water, how it's managed and so on, and general commentators on the rural sector to look at articles on the water issue. You'll find water is probably one of the more interesting and in a sense accessible aspects of understanding the rural world, even if you're not there at present. So I encourage you to read a bit more, get a little bit interested in this whole question, this puzzle of water. And if you are the type who really wants to work out everything that there is to know about these topics as we go through, come back to that question of what is the right balance between water and land, what we really should do. There's one other question or set of questions that we should leave you with as well, and that is the question of what happens as we go down through a river system between the country and the city. If farmers are going to be paying lots of money to get their water property and so on, what does that say about the towns and so on that are going to be also wanting to draw water out of the river to be able to run the town and the industry and the communities and so on that are in it? That's a separate issue and probably more of a social issue or a community issue than a economic one. And the last question, of course, which does really deserve some attention, and just put the antenna up with an aim to actually sort of read what's written in this area critically, and that is the question of environmental water, the importance of keeping a little bit of water slushing down the river in order to make sure that all the fish don't die and it all gets to be a bit of a putrid mess and so on. And, that question of environmental flows, if you think about it, is a relatively recent question, because it's only in relatively recent times that we've been able to suck so much water out of rivers that we mess them up pretty close to totally. On one hand, you've got some people saying that all this environmental flow stuff is a lot of baloney and we should just let it flow when it flows and let it stop when it stops. Then on the other hand, you've got the other extreme, which is this idea that we shouldn't pull any water out of the river at all and we should let it all sort of flow along its merry way because that's nature and we're only nasty alien invaders that are a bit of a blight on the planet. Somewhere between those two poles of thinking is probably a reasonable solution, and it is good for you to get involved in these issues. Like everything else, it's a good idea to remain open to where the facts take you, because in some cases you'll find that the facts will take you to a very different destination to what the popular media and maybe even your school experiences has brought you to. And that's an adventure which will probably take a lot longer than your undergraduate studies to complete, but it certainly makes life a bit more interesting.